Session. Okay, so in today's topic, we are going to discuss about data blending and how to use data blending and what is the difference between data blending versus joins, and how to blend your data and how data blending is useful other than doing joins, and in which cases we need to use data blending instead of joins. So we'll see that. So basically, data blending is a method for combining the data. So there are three methods. So we can use joins and we can use data blending. And apart from these two, there is a new uh, option, relationship. So this got added like 2 years ago. So earlier we used to have only joins and data blending. So data blending is a method for combining data that supplements the data from one data source with columns of data from another data source. So basically, if we need any columns information and you want to combine it to one table, so we use data blending or joins. So usually you use join to perform this kind of data combining, but there are times depending on factors like type of data and its granularity. So if you do a join, what happens is it will create a physical table. So if you have data which is like different levels of data, let me tell you an example. In one table, you have country and state and sales. In another table, you have country, state, and city and profit, let's say. Okay, so if you do join to this type of data, so here the level is different. The dimension levels are different. So here you have 2 dimensions, but in this case, you have 3 dimensions. So earlier when we did joins, we have used, so let me show you. So then we had the number of columns which we are using. So it is same. So then there is only one name dimension. If you see in join 2, there is only one name dimension. So if you have the level of granularity is similar, then using joins is a better option. But in case if you have different levels, so when I say different levels, if you have in my first table, if I have country and state, in my another table, if I have country, state, city, so one more level, I have a extra column. So if I combine these two tables, so I will get a Cartesian product. Cartesian product is nothing but duplicate records I might get. So let's say if you see in this scenario, sorry. So in this scenario, you have Taylor and Alex, and when Taylor is matching, you are getting the Taylor record, only one record. And when Alex is matching, you are getting Alex record. Let's say if I have one more column. Let's say if I have one more column, like I want to have number of cars, different cars they have, different list of cars. So I want to show different list of cars. Let's say Taylor has BMW and same person has Audi car. Okay, and the eye color is same because it's the same person. And when you do a join here, so in this case, if I do a join, so Taylor is repeated twice. So Taylor is repeated twice, and you will get 2 records here as well. So the count for number of siblings will increase. So let me take this join. Let's say if I'm doing an inner join. Let's say if I'm doing an inner join for this. Sorry. Yeah, so let me, if I do an inner join for this, so what will I get? So I'll get Taylor. So Taylor record I will get. So let me copy this. And I will also get this first record. Okay, first record which is matching. So Taylor name, I'm joining it based on the name column. So Taylor name is matching, so I am able to see Taylor information. And again, it will search for Taylor. So in first row, we have verified and we got this, it is matching, we got that record. And in the second row, it will check again. So it is also matching. So it will fetch the same information again. And you'll get this record. Okay, so here the data is correct. So you have Taylor, and Taylor has Audi car and BMW, and eye color is also matching, which is blue color. But if you see the number of siblings, so number of siblings, Taylor had only 2. Hello, are you able to hear me? Okay. So I was telling about this Taylor. So if the name Taylor is matching with the other table, so it will get the first record. And again, it will check for all the records one by one. So again, second row is also matching. So it will fetch the second record as well. And it will copy the same record from the table. So that is why you get a duplicate record. In this second table case, you getting a duplicate record is fine. Why? Because you have the information for that record. But in case of the first table, so this same record is getting repeated. Why? Because it is matching again. So the number of siblings information it is showing is wrong. So why? Because the data is at different levels. So let's connect to this data. Let me do a save as. So let's connect to the same data in Tableau. Save as, and I'll save it in desktop. Data blending. So data blending we use mostly when you have different number of columns in the data. So I'll use this to connect to Tableau server, Tableau desktop. So joins mostly you should use only when you have same number of columns, or otherwise you need to, if you want to get the any particular columns information from other table, then you need to use. Otherwise, it's better to choose data blending. So let's connect to this Excel file. Desktop data blending. So joins. So this is my first table which has number of siblings, and I will show you if I do a join 2. Double click on this. So basically for Taylor, if you see, it is giving you 2 records, even for the first table as well. So number of siblings information, it is showing you the wrong information. Basically, it is doing a double. So let's see how we can make this correct. So let's connect to join 1 first, and let's connect to data blending again and say okay. Edit data source. Let's connect to join 2 table. So this has Taylor and different list of cars that Taylor has. So I have taken this 2 joins or 2 tables separately. So in join 1, I have name and number of siblings, and in join 2, I have a list of cars and name and eye color. So now let's see how we can get this information without doubling the values. So I'll take the information of name and eye color, different list of cars, and I need to join it based on the name. So here joining, how we do is, so earlier in while we were doing joins in Tableau, so we were doing it here. So we were trying to put the condition here. But in data blending, we can just give here itself. So whatever you take, whatever the columns that you take from the data source, so this becomes your primary data source. Okay, primary data source is identified by blue tick mark. Blue tick mark, and I have taken columns or fields from this data source in the first time. So first time whenever I dragged it from here. So this becomes my primary data source. And whatever columns that I drag from the other data source, so that becomes my secondary data source. So now I made a linkage. Whenever I made a linkage, you can see that is showing a orange tick mark. So that means it became a secondary data source. Now let me show. So here I can see the information of Taylor and Alex, and it is also giving me the same information. Like whenever the Taylor is matching, so it is able to show the information. So let me remove this different list of cars. Okay, so whenever I remove this different list of cars from the data, so what is the exact value it has? Taylor has only uh, two number of siblings. So if you go to the data, so there are only two siblings for Taylor. So that information it will show you. And whenever you put or you add different list of cars, so it will show you 2 again. It is not combining the data. So whenever you remove, what is the actual value it is showing? So this is about data blending, where it is not combining the data, where it is not doing a Cartesian product. So you don't get any duplicate records for this. So whatever is the actual value, that it will show you. So let me show you in joins how it shows. So this is about data blending, and let's connect to the same table and let's do joins. So joins will give a different output. So join 1. So let's do reverse way. Put join 2 first and double click on this. Join 1. Okay, so let's do a left join and say okay. Now put the same columns as similar to this one. Put name, eye color, and number of siblings. So name, eye color, and number of siblings. Sorry, I have not done a join. So join with 1 second. Okay, so I need to pick from this. So just remove this. So this is basically the join one. So I'll just rename it. This is join. And these are the examples for data blending. Data blending, join 1 table. We say okay. And data blending, join 2 table. Rename. Join 2 table. Okay, so now let's see join. So I have joined it based on the name column. So you can see the join. I have joined it based on the name column, and I can see the records coming. So Taylor has 2 records, and every time when I join it with other table, so it will do a duplicate of number of siblings as well. And let me take the same thing. So name, eye color, and number of siblings. Okay, so here it is showing you the wrong information. So when I take this number of siblings, what is happening is it is creating one more record and it is showing you the wrong information. But in case of data blending, so this is joints. So in case of data blending also, I'm taking the same number of columns, name, eye color, and number of siblings. And but it is showing you the right information. So what are the number of siblings they have? And when you take, even you can see the different list of cars as well. Okay, you can still see the different list of cars information, and also you can see the uh, information of number of siblings as well. So this way, we can get the information without getting the Cartesian product. So let me just take the different example where we will take these two data sources. So this particular table has information of user ID, district, level, and in the other one you have branch, patron ID, and district and level. Here the columns are different. So you see user ID and patron ID or mapping columns, or so just like name column, we have user ID and patron ID where we will do a join, and district is same, and level is also same, and a column is different, which is type column. I have a type column in the table A and branch column in the table B, so which is different. So let me just connect to these files. So let's create an Excel file. So I will show you what will be the output when you do join and what will be the output when you do a data blending. Any questions as of now? Table A. Yeah, Rakib. Mm-hmm. Hello. Yeah. Mm-hmm. Automatically though it is showing two. So if you see this one, so what is the number of siblings here for Taylor? So in the information, what is the number of siblings for Taylor? It's two, right? So when you do a join, what is happening is, so there are two Taylors in the other table. So it is giving you uh, the wrong information, which you will get this twice. So this record you will get it as twice. Why? Because this record is repeated in the other table. So when you do a join, what happens is every time it will check row wise, and whenever it matches, it will give you those many times that record will get repeated. Even it is repeated thrice. Let's say if it is repeated thrice, so you will get this record three times. So the number of siblings will become six. So which is wrong. So Taylor has only two number of siblings. So if you do a join, what happens is it will show you the wrong information. But in case if you, yeah, when you have different number of columns. See here I have only name column, and in join 2 I have two columns, two dimension columns. So in that case you will get duplicate records, which will not be the right result. So in that cases, mhm. Yeah, please. Who's that? Yeah, correct. Yes, correct. So basically we do. So it does a left outer join basically, but it will aggregate and it will show the information. Yeah. Mhm. Okay, let's say this information is there, right? So I'm just taking an example. So we'll take this example only. Okay, so this is my main table. So it has Taylor and it has information of list of cars and eye color. And let me take this table also. Okay, so I'll just do a left join for the sake of discussion. Well, if I do a left join, I'll get the entire table from the left. Okay, and I'll get matching records from the right table. So let's take the headers first. So matching records. So Taylor, it will check row wise. Taylor is matching. You get this record. Okay. So first row is completed. And next row, again Taylor is there. Again Taylor is there. Again Taylor is matching. So it will get this record. Okay. And Taylor is there again. So this is completed now. And it will check for Taylor. In the first row itself, it is there. It will copy this. So this is also completed. And next Alex. Again, it will check row wise. Taylor it is not matching, so it will not fetch this one. Alex is matching, so it will fetch Alex. Okay. And Morgan. So this is completed. And now Morgan. So it will check for the first row. Morgan is not matching. Alex is not matching. Shannon is not matching with Morgan. Trace is not matching with Morgan. So it will not fetch any records. So these are nulls. Again, same. So this is also completed. It's not matching. And John, again, it will check with Taylor not matching, Alex not matching, Shannon not matching, Tracy not matching. So it will give you null. Okay, so this is how left join works. Yeah, yeah, Rakib. Mm, hmm, that's the data. Yeah. Okay, so yeah, so basically he has only two siblings. So, but in information you got here is, so it is showing you six basically. So whenever you try to fetch information, so name. So I want to see only names and let's say number of siblings. Okay, so in Tableau, if I try to fetch this information, so it will show names, all the four names based on this. Okay, and it will do an aggregation. So it will give you six for this, and Alex is three, and these are nulls. And if you see, as I have done a join, and there is a repetition of records, and it will show you this many records. I mean, which is a wrong information. So he doesn't have six number of siblings. He has only two. So So in this way, you will have a lot of records which will be repeated. So in this case, I have shown you only 3, but in real-time data, you might have some extra number of records that you might have. So it is very hard to find what is the exact value. So this is an example for like a measure. So to consider this number of siblings as a measure. So the output that you get, you might not get the correct value. So in case if you do data blending, sorry, in case if you do left join. So this is based on joins, but in data blending, what it does is internally it will also do a left join only. But what it does is it will aggregate and it will do a join. Aggregate and do a join. So when I say aggregate and do a join, so I'm just joining based on the name columns. So I'm just joining it based on the name columns. So when let's say if I want information of name and number of siblings, name and number of siblings, so it will take only one Taylor into consideration. As I'm taking only name into consideration, so one Taylor only it will consider. Okay, it will consider only one Taylor, and it will fetch you this information directly. So it will not create duplicate records. And when you try to get the information, so it will give you only those records without creating any duplicates. So let's see this one first. So I'll show you how this is getting created. So, yeah. So basically, this is my, yeah. So whatever I have taken, so this is my first table, which is on the left, and this is my second table, which is on the right. So I'm doing a left join based on the name column. And the output that I get is like this. So Taylor will be repeated and Alex, Morgan, John will be there. Taylor is repeated and Alex, Morgan, John is there. And here I have added one more extra record. So that is why here it is showing you 3. And in earlier we had only 2. Okay, so now let's see. So based on this join table, data blending, based on this join table, so I'll try to fetch the information of name and siblings. Okay, so it is giving you wrong information. So Taylor has only 2 number of siblings, and it is trying to give the wrong information because of Cartesian product. It is giving you multiple reports. And now I will try to fetch the information from data blending. So data blending is something where it will not do a combination in the starting itself. So the tables will be separate only. So you see this name, eye color, different list of cars. So this is separate. This will look like a separate table, and this will also look like a separate table. So this is another table. Yeah. So name and number of siblings. And when I try to fetch the information, so here I want to see name as well as eye color. And in the other table, I have the information of number of siblings. So this is a connection that I make. So until unless you make a connection, you won't get the data from the other table. So this is like a join. So until unless you make a connection between these 2 tables, we will not be able to pull the columns from the other table. So now if I take this number of siblings and make this connection, you see this Taylor is coming, Taylor value, the number of siblings is coming as 2. So it will not do the Cartesian product. So it will fetch the right information. Is it clear? Okay, so this is the main reason that why we use data blending. So when you have different number of columns, and we can use data blending in this option, where to not to get the duplicate records. And I will show you one classic example for joins as well. So let me connect to sample superstore. So edit data source. Okay, so let me remove this. Okay, so I will show you information of orders table, and then people I have the information of regional manager. So basically in orders table I have information of order ID, order date, ship date. So all the details related to customer when the order is placed, and what is the product that a customer purchased, and what is the ship date of that particular product. So all those information is available, and where is that superstore region. So address and everything is stored in this particular orders table. So in orders table, I have all those information, and I have in another table, I have information of regional manager. So for each and every region, central, east, west, and south, I have a manager, but that information is in a different table. Okay, so if you see in this particular detail, we have only the region column. Okay, and this is basically related to customer and product details. So the data that I have, customer and product details in orders table. Okay, so I have customer and product details in orders table, and then people table, I have regional manager information. Regional manager info in people table. Okay, so what I'm trying to get is who is the manager for this particular region? Any questions? Okay, so who is the manager for this particular region? Let's say for central, who is the manager? For east, who is the manager? For south, who is the manager? So that information is available in this one. So to get that, they are using relationships. So instead of that, we can use joins as well. So let me just remove this. So orders table has this one, this much of data, and let me show you the people data. Okay, so if you see people data, you have region name and the regional manager information. So when we do a join between region and regional manager, so you can see next to that column itself, so you can see the regional manager information. So I'll just remove this. So in this orders table, so if you see, there will be no column called region manager. Okay, so now I want to see next to this column, I want to see regional manager as well. So what I will do is, I will join with people's table, do a left join. Why? Because in orders table, you have the lot of information. So in that case, it's better you do a left join, because so this is your main table. Okay, so this is your main table. So as you need to get more information from this table, so it's better you do a left join, because you'll get left all the information and matching records from the right table. So I will do a left join, and region, I will join it based on the region. And when I do a join, So it's already been joined. I can see regional manager here. Yeah. So who is the manager for Central? Roxana Rodriguez. So all this information, you can fetch it. So to fetch the information of the columns, to fetch any uh, column information, so you can join with a different column and you can fetch the data. So that is how we can get the information. And I'll show you about relationships as well. So without doing a join, we can do this. So basically this is called as a physical model. So if you do joins, that is called as physical model or physical layer, I would say. Okay. And if you do relationships, then it is called, that is called logical layer. Okay, I will tell you why this is called as a physical layer and why this is called as a logical layer. So physically you can see that columns here. So these are combined. So regional manager and region got added into this particular table. So the combination of these orders and people combined together, you can see a physical table that is formed. So you can see those columns. So there are some 10 to 12 columns in orders table, and there are only 2 columns in people table. So 10 plus 2, you got 12 columns, combine these together. So this 12 columns will be physically existing in your Tableau desktop. And let me save this. So this is your joins in sample superstore. So I will publish this in Tableau public. So try to download and try to replicate this in your Tableau desktop. So I'll just save it as joins. Say okay. So now I'll do relationships. So I'll just connect to the same sample superstore. So as we discussed in the starting, so uh, there are only three ways where we can combine the data. So using joins, data blending, and relationships. And edit data source. So let me just remove this returns. Okay, so these two tables are not combined. So whatever columns which are there in orders, you can see that here. And whatever columns which are there in people will be there like that only. And join condition is based on region. Region from orders table is joined with region from people table. So here we are just using, and in the data you can directly, I'll just rename it as relationships. Say okay. And you can make use of, let's say, the region and region manager. So you want to get the region and regional manager information. Okay, still you, so even if we are not doing join also, by using relationships, we can get the information. So basically in order table, in this table, we don't have the information of regional manager. By doing a relationship with people table, we are getting this information. So you need to write this condition saying region has to match with a region column from people. So I'll just drag it here. And these are called noodles. The connection between these two tables, you are getting a line like this. So those are called as noodles. So Tableau will automatically find out if the column names are matching. So it will automatically select those columns as a joining condition. If the names are different, you can manually select those names and you can select that. A noodle is formed between these two tables. And so you can see in orders table, or you can see the regional manager for the whole data. So let's say customer name, or let's say uh, products. So you can see, let's say, let's take state, and which in this particular state, who is the manager for that. So if you do not have this regional manager information, so you will not be able to find out in which state who has to contact and all. So it's by using this people table, we can get the information of regional manager. So that is the importance of joins. So whenever you want to fetch some columns information, in that case we use. And in our example, where you have duplicate records. So in this case, what we are trying to fetch, we are not trying to fetch the dimension information. We are trying to fetch the fact information, number of siblings and all. So, in number of siblings also, the values are getting duplicated. So which will not give you the right values. But in here also you will have duplicate records. So you might get Cartesian product, but here I'm not considering any measure values. I'm just trying to fetch this regional manager value, which is a dimension. In case of dimension, it is okay. You can have any number of products and all, and even if it is giving you Cartesian product and all, that's okay. But when you're trying to get the information of measures like this, okay, so if the records are getting repeated, so you will get the information which is not correct. So the Taylor has only two number of siblings, but it is giving you six, which is wrong. Okay, so let's say if I am trying to get the information of, let's say, if I have one more column like, let's say father name, Maze, let's say, okay, father name is Maze. And even if the father name is repeating, Maze, okay, in Tableau, if I try to get the father name, okay, so in Tableau, if I try to get the father name, it will just show you Maze only. So you will not see, like you will not see the duplicate values. Why? Because even if it is repeating multiple times, let's say, if I go to sample superstore data, so category is repeating these many types. So office supplies is repeating these many times. Furniture is also repeating so many times in your data. But when you drag it, so you will only see three categories. So in the complete data, whatever information is there, it will show you only three categories. But you have these many values. It will not show you that. In the same way, in case of dimension, it won't be any problem, even the data is getting duplicated or not. Okay. So it will fetch you only one value. But in case of measures, it will be a problem. So it will not give you one value. It will do an aggregation and it will give you the wrong information. So in such cases, we need to do data blending. Any questions? Hmm. Yeah, correct. Hello. Yeah, it is correct. Yeah, that's correct. So when you have dimensions, when you're trying to get the information of dimension from other tables, then prefer joins is preferable. But when you're trying to fetch the information of measures, so getting duplicate values will cause some issue. So you will not get the right data. So in such cases, it is preferable to use data blending. Hmm. Okay, let's say so. Why I'm saying number of dimensions is, so let's say if you see this, where is this? Yeah. Okay, so here one dimension got added, different list of cars. So because of this, I am having Taylor has more records. Okay, so this is a different level. So if you have different number of dimensions and you are trying to calculate measure values, so then it's preferable to use data blending. Hello. Okay. Yes, correct. On the fly. It does on the fly. So in here also what it has done is, so Taylor it has taken and so we are trying to fetch the information of this one, Taylor and number of siblings. So it will aggregate to Taylor level only. So Taylor has two number of siblings, which will give you, that's it. So but join is not doing that way. It is not aggregating this thing. For each and every record, it is giving a record. For every Taylor, it is giving a record. It is not doing an aggregation. Got it? Okay. So basically, as I'm joining based on this two columns, so only one record will be considered according to data blending. So even if if it is having three records, so based on data blending, what happens is it will consider as a one record and it will give you the information. So it will not do a Cartesian product. So okay, joins you see it as physical table. So if you see, so there is a physical table that is created. So I'm combining orders and people. So whatever information which is there in peoples got included in this table. So regional manager, regional people, this is from people table. It has combined as a physical table. Okay, so this is joints. And when you see in relationships, these are two different tables. Orders, you have a separate table, and people, you have a separate table. So in people, you have only two columns, region and people, and orders, you have these many columns. So it will not combine these two data sources or two tables. But when you try to fetch the information in relationships, when you try to fetch the information, so I'm trying to get region and also regional manager and category from orders table. So it will still be giving you the information. Basically, it is like data blend. Mhm. Advantage and disadvantage. Okay. So let's, yeah, both are giving you same information. Yes. In this scenario, both are giving you same. Okay, so I'll tell you importance like the relationships, it won't change the, so if I want to add returns also. So here I can add returns also. So and this is joined based on the order ID. So whether the order is returned or not, so that information is there in this one. Okay. And when you do physical join, right? So physical join will change the shape of the data. So sometimes what happens is you get some duplicate records or values you might get different. So in this case also, you see the number of siblings is showing you different records. In the same way, you will have sales and profit in our data. Okay, sales and profit in your data. So if you keep on doing joins, right? So it will change the shape of your data. You might get sales, profit, quantity, all these measures. You might get duplicate records and you might get the wrong information. So that's why we use relationships. So in relationship, what happens is it will not combine the data. So you see all your tables separately only. But whenever you want to get the information from the other table, and you can, it will make a connection. Okay, it is like a improvisation in data blending. Okay, so relationship is nothing but they have made some improvements in data blending. So you don't need to do data blending also. So it will fetch the information from the other table without doing any joins. So this is the order ID which is available. So let's say if this order ID is getting multiple times and you are trying to do a physical join, so you might get sales, profit, all the measures might be getting duplicated. So to avoid that, we can use this relationship model. Is it clear? So after implementing this relationship model, so most of the people are using relationship model only. And when you want something to be like physically, let's say in joints, you see this, right? So you know that this is not making any Cartesian product. So in this, you don't see any Cartesian product and all. So in orders table, you have 4 regions. In people table also, you have 4 regions. So there will not be any duplicates in this. So in this case, it is okay. Physical table, by creating physical table, it will improve the performance. Why? Because we are creating a physical table. So while creating only, it will take time. And while dragging and dropping the columns from this, it won't take time. But in relationship, what happens is, so every time when you drag and drop or when you use this relationship, every time it has to go through this process. Okay, so you are taking some columns from orders table and some columns from people table. So every time it has to perform this operation. So it has to make a connection between this and you are trying to get some information from returns table. So every time this process has to happen. But depending on your requirement, so only if this model is giving you the right information, then we should not think about the performance. We should go for this. Why? Because in physical join, you are getting some Cartesian product and all. So then in such cases, we go for relationships. And whenever you think there is no Cartesian product and in physical join, you are able to fetch the information properly, then go for a physical join. Any questions? Okay, yeah. So, yes, correct, correct. Yeah. Larger number of columns and whichever has the measure values. Fact table basically. Yeah. If you're taking measure values from that table, then you need to consider that as a primary table or the left table basically. If you're trying to fetch the information of measures, then it's preferable to do data blending or relationships. Otherwise, there might be some Cartesian product or duplicate records will come. So if duplicate records are coming, so you will not get the right values for measures. For dimensions, it is okay. So duplicate will records will not create any problem uh, related to dimensions, but related to measures, you will get issues. Why? Because you have seen it here, so it will create these records, which will give you output wrong. So then it's preferable to use data blending or relationships. Yeah, yeah, Rakib. Huh. So let me do relationship for this join two and join one. So join two table has this Taylor and Alex Morgan, John information, and in join one. So if you double click, then you can do joins. If you are not double clicking and you are just dropping the other table, then it will do relationship. So relationship you can identify, you'll see these noodles and all. So these are called as noodles, nothing but the connection between two different tables. So these two tables are separate. Join two is separate and join one is separate. And now I'll try to fetch the information of name, eye color, and number of siblings. Name, eye color, siblings. Okay, so in this also it is not doing any Cartesian product. In this also I can see number of siblings. Yes, two, which is correct. So basically this name is getting repeated twice. Even if it is getting repeated twice, I'm not able to see this number of sibling is getting repeated. So I will be able to see the right value, the number of siblings. So if you want to see this number of siblings column here, just type in. So this way we need to use uh, relationships or data blending instead of joins. So this is the scenario. So if you are doing joins, what happens is, so as we have seen here, so we will also take name, eye color, and I'll take siblings. Okay, so here it is giving you 4. Why? Because that name is repeated twice. Okay, so in joins, what is happening is, as this name is repeated twice, so Taylor value is also repeating twice. The number of siblings value is also repeating. So that is why it is giving you double records. So, and this is creating a physical table. So we will not be able to change anything here. So only in case of relationships and data blending, we can see the correct data in this scenario. Okay. Is it clear? So I'll show you by connecting to this data. Okay. So this data I will show you tomorrow by connecting to this data how we can do data blending and joins. Okay. Hope today's session is clear to everyone. Any questions as of now? Yeah, Rakib. Mm-hmm. Can you repeat your question once? हाँ 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 हाँ. We can specify that. So even in data blending, even in relationships, we can specify which one to select. So if the name, I mean, if the header names are same, Tableau will automatically check that. Okay, so you can click on this noodle and you can see the condition. If you want to change the joining condition, you can change it here. So Tableau will automatically pick it. Even for data blending as well. So this is for data blending, I guess. Okay, so even for data blending, when we have seen, yeah, so here we have done data blending. So you can see the connection only for name. So names are matching, so you can get this linkage symbol. If the names are not matching, it will not come. So then what you need to do is go to edit blend relationships. Here you need to manually select those names. If the names are not matching, yeah, by which column you're trying to do a join. So here you can manually do that. So go to data and click on edit blend relationships. Okay, so that's all for today's session. So we'll continue tomorrow. Okay. Mhm. Edit blend relationship. Select. Yeah. So like this. So you can take, so this is your primary data source and this is your secondary data source. You can see the list of columns in secondary data source and you can match it. So then you can see linkage like this. So there are three, I mean, in data blending, this is the way where we can do it. If the names are different, this is the process. And in joins, you can directly select here. If the names are different, you can directly select the column here. And so this is your left table columns, list of columns. And these are your right table list of columns. So whatever columns that you want to put as join condition, here you can select. And I'll show you in relationships as well. So in relationships, you need to click on the noodle. So click on this noodle symbol and you can see, so this is the data from order. I mean, these are the number of columns from orders table and these are the columns from people table. So which column you want to use as a joining condition, you can select here. For returns also, so this is your orders table columns. These are your return table columns. So Tableau will automatically identify in this case. Why? Because the names of the columns are matching. So it has chosen these two columns as a joining condition. Yeah. Any other questions? Left approach. Mostly we do left join and all. Yeah. So depending on the scenario, we might use other joins as well. Have you attended yesterday's session? Yeah, in yesterday's session, I have covered all those joints. Okay. Yeah. Okay. Any other questions? Okay, then. Thank you all for joining. We'll continue tomorrow. Yeah. Yeah. Thank you.